This paper explores antigen clasping by two antigen binding sites of an exceptionally specific antibody for histone methylation. So in specific, this paper is looking at the site H3K9ME3 and H3K4ME3, and the recombinant antibodies 309ME3B and 304ME3B, to explore a very unique and rare property in which there's a dimerization of these antibodies, which causes a clasping of the antigen through two separate parts. So this is going to use the antigen binding fragments FAB1 and FAB2. These are seen in figure 1 with FAB1 on the bottom, which contains an aromatic cage, and FAB2 on the top with the A1R2 binding pocket. These are two separate basically cavities in the protein that allow for antigen to be clasped in between them. That's seen here where the peptide fits nicely in these little cages. So the recombinant antibodies 309M3B and 304Me3B have very high specificity compared to the regular A varieties. And this can be seen in figure 5, where 309 binds almost exclusively to the KNME3 and 304Me3 binds almost exclusively to K4Me3. This is because these two sites working together account for more specific size. So the 309 and 304 have about sizes about 20 angstrom differences and 7 angstrom differences between these two cages, which are very specific. They're very small and allow for a very specific clasping of these two different antigens. In figure 3, you're going to see a closer picture of the aromatic cage found in FAB1, and figure 4 shows the A1R2 binding pocket in more detail. The reason that these are more specific is they use more CDRs through antigen clasping, which allows for more specific connections. Usually, there's no intermolecular dimerization. So as seen in figure 6 here, we have a regular IgG or immunoglobulin structure, where the two binding sites don't come together to clasp an antigen. The engineering in this paper used a different kind of structure called a long neck SCFE FC, which actually uses a long linker to create a dimer of the two FAB heads, which will clasp the antigen in a more direct way, basically. So comparing that regular IgG and the long neck, we have actually a higher binding property of the long neck SCVB, which means higher specificity, but a lower cooperativity, which means that it will be altered less in the process. So basically, this research will allow further exploration of histomethylated regions, which will increase our ability to explore specific antigens in epigenetic related fields. Yes, so this is a very rare way that antigens are basically clasped, but through directed evolution and other protein engineering, such as the long neck system here, can use it for further research in different antigens. So thank you.